Okay, so members, now in this lesson we are going to see these types of integrals. Like we've seen that we need sometimes to separate the numerator. Even these types of integrals, we need to separate the numerator using the above formula. Please don't forget to subscribe to the channel. Now, the way we separate the numerator of these ones is different from the way we separate numerators when the functions are polynomials both in the numerator and denominator. So if this is the function, these are the functions we have, this is how we split the numerator. So now I'm going to handle these two, but the hint I'm going to use when you differentiate sign, you get cos. When you differentiate cos, you get negative sign. So now if you have this now, I need now to separate this numerator. So the numerator will be equaling our numerator is then minus 3 sin theta is going to be K1 into the derivative of the denominator. When I differentiate, now I need the derivative of this. So I differentiate this, the differentiate sign, I get cos theta. When I differentiate cos, I get negative sin theta from here. Then plus K2 into now the denominator itself, which is sin theta plus cos theta. As simple as that. Now here we need to get these constants. What are they? So we compare coefficients. Yes, we compare. If we compare now, is that if I compare now for cos theta first, this side I have 9 equaling to, this will be K1, then this will be K2. Then if I compare for sin theta, this side I have negative 3, this side I have negative K1, then this side I have plus K2. So if we solve those two, you see this one is equation 1 and this one is equation 2. If I add them, if I say equation 1 plus equation 2, if I add them, I'll be having 6 equaling 2. This goes away, this will give me 2K2. Because I can say, why am I adding? Because I said I can eliminate K1. So my K2 will be 3. If my K2 is 3, from here, if K2 is 3, when you take the other side, you see that if K2 is 3 and you take this side, you see that now my K1 will be 6. Even if you put it here, K2 negative 3 minus 3 equal to divided by negative, okay, will be that. Mean that the whole of this now 9 cos theta is equal to K1, which is 6 into now sin theta, then plus K2, which is 3 into sin theta plus cos theta. So now, what is this integral? I'm going to just substitute the things. So now, the integral of 9 the whole over the theta will be now, I'm going to take this 6 out into now cos theta and then sin theta over this denominator, which is the theta, then plus 3 into now the whole of this is going to be over the denominator, which I'm dividing through the theta. And from there, this is the function and its derivative. So this one we are going to be having 6, then natural of sin theta plus cos theta, then plus 3. You start this one cancels, then integral the theta, which will be now 6. Then plus 3 theta, then plus the constant of integration. So that's how we handle part 1. When I come to this, the same idea, you separate the numerator. So now my sine theta will be equal to K1, the derivative of the denominator. When I differentiate this, I get negative sine theta. Then minus, when I differentiate sine, I get cos theta. So that's the derivative of the denominator. Then plus K2, the denominator, this is our denominator. As simple as that. Now here we compare coefficients. If I compare, now if I start with cosine theta, you see cosine theta, I'm going to be having this side is 1 equaling to negative K1, then this and this minus K2. When I come now for cos theta, this side there is no cos theta, so it's 0 equaling to this side I have negative K1, this and this, then this side I have plus K2. Then we can easily see this one is equation 1, this one is equation 2. So that this one is having the same sign, so I can add 1 plus 2. When I add this will go to negative 2K1, this will go to 0, then this will be a 1. Imply that my K1 is negative a half. If K1 is negative a half, from here, it's not even K2 is equal to K1. My K2 will be also negative a half. So now the whole of this will be now K1 which is negative. Then plus K2 which is a negative a half. Now, where is this? I'm going to put the whole of this in that formula now, in that integral. Will be now, this is a constant, I'm going to pull it out, then I separate, then I have sine theta, then minus cos theta, the whole over denominator, this theta, then plus, this is negative a half into over the denominator, our denominator is here, the theta. So from here, start when I differentiate this, I get what is half. So it's a function's derivative, which will be a half natural of this. Then minus a half integral, so that the whole of this is going to cancel with this. So it will be remaining with the theta, which will be negative a half. Then minus a half theta plus c. So in simple terms, members, that's how we handle those equations and in those integrals. Don't forget to subscribe to the channel. Send in more questions you want me to handle. I wish you the best.